Well, hi, and welcome to my shop here on July 6th today. I took the day off yesterday to do other stuff. Back in here today after thinking about it. Just going to make a quick review here where I'm at with this guy. So, seems to me if I put an audio signal in here at the volume control, it stays looking pretty much like a sine wave all the way to here. When we get to here, it looks wonky. So I'm thinking, and I don't know what else to think, that transistor has failed. So I think what I want to do today is I'm going to remove this transistor from the radio and then test it and see if my guess is correct. That's the plan. Probably what's going to involve a long period of time today searching through some old transistors looking for a suitable replacement. That's probably where this is going. Okay, so which transistor is it? Let's take a look this way. Okay, so the transistors in there, we start at the speaker end of things. So these two transistors here are what are driving the speaker. The input to these comes out of this transformer. The input to the transformer is coming from this transistor right here. And that transistor gets its feed from this transistor right here. This is the one I want to take out though, this one. That would be my plan. Now the thing about taking out a device with 3 leads on it is it can be very tricky to get it out. So, just in thinking about this, the best way is going to be to try to remove as much solder, in this case, as possible. So the three legs are arranged this way. This way. I think they're right there. Bing, bing, bing. Right there. I'm going to use my solder sucker here. We'll see how this goes. These 3 here, right? Yep. Well, I'll say yep right now. Let's take a look at how good that went. I think I have this on autofocus here. It may not work out so well. That's pretty good. That's pretty good. I'm going to wiggle the transistor and see if any of the leads are actually free already. Probably not. All still sort of tack soldered in there. Not exactly sure what I was doing there. pull on it. I always wonder, when you're applying so much heat to these components when you're soldering them. That's one. Might be two. Three. Three of these are moving. One of them has a hook on the end of it here. Okay. There it is. There we go. This doesn't say T2 at all. It's supposed to be a 2T. I got the numbers mixed up. 2T6. According to that. Let's take a look under the closer camera here. And bear with me. I'm just going to turn off the automatic focus here. Oh, it is off. That's good. Set it there. Okay. D65 EHO. There's a dot on one end there. See the dot? Got to be marking one of these leads, giving it some notion on which lead is what. But that's not at all a D. Now, you know, how critical is it to get exactly the right transistor reader? I don't think it's critical at all. I think it's far less critical than a vacuum tube. So we got to find out about this transistor, its ratings and stuff like that, and just find another one that's similar. I'm pretty sure this is going to be germanium here. D. Okay, well, that's enough looking at it. Let's put it in the tester. See what happens here. Now this is the greatest little thing here. I think there's probably lots of these instruments around now. I couldn't believe it when I first heard about this. You just hook these leads up any old way. Well, it's like a dream come true. You don't have to tell the machine what it is you're testing or anything. You just hook up whatever component you want. There we go. There we are. What do we make of those readings? So you have 196 millivolts. That sounds like the forward voltage drop. This is going to time out in a moment. That sounds about right. And then I don't know what to do with those other readings. The one on the bottom there is 0 milliamps. It's a little suspicious, wouldn't you think? Okay, that's some information to look at. I'm really not sure if this is telling me it's good or bad. Well, it's actually the next day. It's now July 7th, and I did manage to find some suitable potential replacements for the original transistor that was in the radio. But I have a quandary here. When I tested this transistor, it showed a leakage current in it. Now I'm not so familiar with all this stuff. So is a leakage current that I measured, we'll do it again with this instrument in a sec, is it indicating the transistor's bad, or how bad is it? So I thought, well, simple matter, I'll just find some other transistors, and germanium transistors, by the way, and I'll check those, and we'll see if the reading compares, and maybe I'll find some with, very low or no leakage. But what I actually found was a bunch of transistors that test very similar to this one. So I'm left now wondering, is this guy really bad? I don't know that it's bad. Is it bad? Are all these bad? These are the ones I've tested here. Are they all bad? Is that what happens? I mean, I think germanium transistors do not have a life that goes on forever. I think they do slowly wear out. One of the failure modes that I have read about is the formation of dendritic metal crystals coming in from the outer can here and penetrating into the capacitor electrolyte, I guess, and then eventually shorting it out or just degrading it to the point where it's no longer any good. Some interesting solutions for that. This dendritic growth thing is a problem in lots of things, electrical. Power cables with solid insulations, like plastic insulated cables, high voltage cables, and other places where this dendritic formation is a problem. So what am I to do here? So I've done quite a bit of research trying to find out, well, what's a typical reverse current or leakage current through one of these guys. Sounds like 10 microamps you shouldn't think much about. 100 microamps, maybe even that's okay. Beyond that, it's not clear. Nothing is clear. There's nothing clear here. Nothing clear, including the weather. The weather here is not clear. So let's start by testing the original capacitor transistor again. We'll see what we get. So quite consistent in how this is reported. So first, the voltage drop across the one of the junctions, anyway, 200 millivolts. That's exactly right for a germanium transistor. The number here, 73. I think that's the gain, but I'm not sure. Some of these transistors over here measure in the hundreds. Whoops, this only lasts so long. In the hundreds, it measure above 100. The current leakage is about 0.2 milliamps, so that would be 200 microamps. Would that be? He says very faintly. But they all show a similar reverse. I'm going to test one of the other ones here, and we'll see. And the last leakage was pretty much at 0 there. So let's get out one of these guys. Did I say I tested them all? I didn't. I only tested 4 of them, but I got such consistent results I just stopped at that point. Here's one of them. This is not an exact match. Like the numbers don't match on these transistors. I don't have exactly this transistor, but the transistor operation is very dependent on the circuit that they're in, and many transistors can be substituted, I'm pretty sure. Maybe you don't get 100% of what the circuit designer wanted with a substitute, but you get pretty close anyway. So there we are. So first, the junction voltage, 200 millivolts again. This one, the current leakage is higher, 300 something amps, 0.3 milliamps. As far as I know, these have just been sitting in a bag their entire lives. This is the first time they've come out to play. I don't really know the history of these parts, but I mean, the leads are completely long. They've never been installed anywhere. Anything's done to them. They've just been sitting around. It's a similar reverse again, 200. 0.2, I better say 0.2 milliamps. See, the B is higher here, 105, and the same junction voltage. So, I mean, it is a good chance I'm just testing a bunch of bad transistors here. They're all bad. I don't believe germanium transistors are being manufactured anymore. I do believe you could put, in some circumstances, a silicon transistor in place of a germanium. Again, it's not going to be exactly what the circuit designer was thinking or designing around, but you may get somewhere. So this one's showing a higher leakage, lower, I'll call this gain. I'm not sure whether I should call that gain. We'll call it gain though. Gain is 68. I think I read somewhere that generally the higher the leakage, the lower the gain. And the problem with this leakage current is it's, well, this says collector emitter. Collector emitter. Yeah, the problem with it is I don't know what the problem is with it. That's the problem. What to do here? So my choices are put a different transistor in that seems to work about the same, see what happens. Put the same one back in, and you know, where does that get me? That actually doesn't get me anywhere, does it? Really, other than claiming to have eliminated that particular transistor. If I put a different transistor in and we get exactly the same result with the radio, then we can be pretty sure to move on from there. If I put the same transistor back in and get the same result, then I may just still have the same bad transistor. Did I say resistor? And if I put a new one in that tests the same as the old one, I get the same result. What have I learned there? I've learned that it's time to go drink some coffee and just stop for a little bit. Oh my gosh, I gotta say good morning again, because it's another day has gone by. It's now July 8th. I'm afraid I left my shop yesterday and got involved in a bunch of other stuff in my house and just never made it back in here. How do you like that? So today I've decided I'm going to install a different transistor than the original one, even though I don't know for sure there's anything wrong with the original one, and I don't know for sure that the replacement one sitting here is really any better. But I can't think of any other thing to do, and it seems to make sense to me now to try this. So first thing I've got to do is I've got to get the emitter base collector pinout arrangement for these two guys understood. So this one has a dot on the side marking this, and this guy also has a dot on the side marking this one. Put them both the same way, and I'm going to use my tester to identify it. This is a great little tester here. My gosh. When I was in college, if somebody had told me someday a thing like this you could buy, you know, for $25 or whatever it is, oh my gosh, I wouldn't have believed it. Yeah, you just hook the part up and push a button, one button, and it tells you everything. Amazing. Okay, so quickly, Jim. Now I'm gonna have to do this again. I wasn't ready. Didn't have my pencil ready here. Whoops! Thought I had everything all set up. No pencil. Nope, not a pencil. Not a pencil. Here we go. Okay, now I'm ready. So each of these leads is numbered 1, 2, and 3. And this thing's going to tell me what 1, 2, and 3 are hooked up to. So I just write it here. 1 base, 2 collector, 3 emitter. Actually shows it up there. 1, 2, 3 BCE. 1, 2, 3 BCE. Yep. Okay, now we got to get the 1, 2, 3 straight on here. So the way it looks is this is, be fooled here. This is number 2. This is number 1. This must be 3. Okay. As it lies, it is 3, 1, 2, which is emitter, base, collector. Now we'll do the same thing with this guy. Just hook these up kind of randomly here. Give us another test of the transistor I've got there too. Good. It's got a B of 118. It's a lower reverse or leakage current. And it's 1, 2, 3 is CBE. 1, 2, 3 is CBE. 1, 2, 3 is CBE. Okay. So 1 is, so we take here like this. So it's a collector. And we go number 2 is the middle, base, emitter. It's exactly the same arrangement based on the location of the dot. I reviewed my video to make sure I know which way this was in the original radio. It's in this way. So put this guy in the same way. We'll see what happens here. Looks like all 3 of the holes are clear right through. Tricky business here. There we go. Okay, need to solder that up. Oops. Put these over here. Okay, soldering here. So we're on our second day of all day gray and rain. Cats are very, very depressed. They do like going outside. So if a sad cat comes in here, you'll know why it's sad. Yeah, we actually went through almost no rain for 4 weeks. Now we're getting almost flooded with rain here. And it's cold outside too. 1, 2, 3. Easy as that. So I think I would give this a 25% chance of solving the problem. And I don't have all the faith in the world at all. Actually, I don't have any faith. I'm being generous at 25%. Okay, we'll put this up like this. Make sure the power is on the ground. Power on the red wire here. Yeah, power on the antenna. Power on the red wire. Switches off. Okay. I'm just using a power supply over here. 4.5 volts. Okay. Will it be distorted? Will I be able to pick something up even? Let me bring my booster antenna over here. Get it at the ready. Okay, here we go. Oh, it works. Let's tune something in.
I think I'm almost a fan of the Tampa Bay Lightning now. It's like, I don't know. I just hang up the Leaf stuff and just root for Tampa. And just say that's stand hold up, you know? Employing the Nikita Kucherov. Of course, we're all in on the Tampa Bay Lightning. The team that defined the era. The team of this generation. A couple of years ago, the Blackhawks. Penguins had a good run there, and then the Penguins went back to back. And they touched it. Before, like the idea that this is impossible in the salary cap era to have the dynamic teams. There's been 4 teams since the salary cap.
Well, it sounds exactly the same to me, except a little bit louder. I think I got more volume out of it, and that kind of makes sense. This transistor I put in has a larger gain, stronger gain than the last one, but it didn't solve the problem. Either it's defective in the same way, and so you're getting the same result, which I don't think is the case. I think it's something else. How annoying is the distortion? It's pretty bad.
I'm just saying, I'm trying to come up with teams that like come front and center with it.
It's pretty bad, actually. You know, to demonstrate the radio operates, it's probably fine, but to sit and listen to it, especially I think if we found a station with some music on it, we would be really disappointed in the way it sounds. So I'm trying to remember exactly where well, basically I've proven it can't be, it's not this transistor. The distortion could still be starting earlier, it could be starting later. Based on the tests I did before, starting later makes more sense. But I don't know. I really don't have any certainty about this. I think some more tests are in order here. Okay, so what I've done here is I've got my signal generator going. It's roughly around 1 million hertz. It's the middle of the broadcast band. Its output is fed to this loop just sitting here near the radio. The radio antenna, of course, is over here. So what's coming out of there can be picked up as a radio signal by the radio. We can hear it. I have a tone playing in here, 1000 hertz tone, so we can hear it. And I have the oscilloscope hooked up to the speaker, so we're starting at the far end of everything, seeing what this looks like. So the scope is not a perfectly clean display. Let me put it on here. Okay. Oh, I see the light is reflecting here. Let me just get this ghostly thing out of here. There. Hey, I'm there too. Okay. So you can, it's hard to see. It's hard to do this with a camera. Get you to see what I see with my eye. So that's not actually too bad. So now there's nothing going on here except the scope is picking stuff up literally from the speaker, like the speaker's an antenna. So that's what I think all this hash out here actually is. Oh, there's a little bit of a shape to it. Now you may realize that I'm having trouble getting my scope to trigger, but I can fiddle with the sweep speed here, kind of manually slow it down. So that's nothing. That's an image of nothing. I've got this thing set fairly sensitive too, 50 millivolts per division. So I'm going to turn the radio on. And we're going to have to listen to this tone. I can quiet the tone down. Let me first get it to stop moving. I'll make it a little bit bigger. There we are. You can see what it looks like. Now again, on the video image it's quite an ugly mess. But there's lots of weird stuff in it. This is not a nice, clean sine wave. I'm taking a wild guess that these brakes, there's brakes in it, have to do with the push-pull. Both sides are appearing. Like it's not like only the upper half and no lower half. Let me put this on a lower frequency here. So now that, that's far from a sine wave. Far, far, far from it. Okay, so now what we're going to do is we're going to take a look at the signal where it let me turn it down this way. There, just turn down the modulation on the signal generator. We'll look at the signal that's being sent into the audio amplifier just past the volume control, or at the volume control really. So let's do that. See if it's the same. Well, you can even see in the long shot, it's definitely not the same. I mean, it's clearly different. Now, is that really the tone? Let me put the tone up. Sure. Now there's still a little bit of stuff in it, a little jiggly stuff. That's probably noise. If I up the output RF strength of the generator here, look at that. Well, this is what we need to work with. So at this point, the signal's beautiful. Let me go up to 1,000. I can see it. Look at that. It's perfect. It's absolutely perfect. And if I go back to the speaker, I've got to go back to the speaker now. Okay. Just bear with me here. I'm just gonna kind of. Okay, here comes the speaker. Let's talk about that. I wish I could kill this sound. Go a little lower lower in frequency. Ooh. So this is a push-pull amplifier, and so the upper half is amplified by one transistor and the lower half is amplified by the other, and there's a point at which the two of them are both going or neither are going as the thing kind of crosses over. You get a little point of distortion at the crossover. I think that's what these are. I think at the higher frequency it's easier to see. Do I know that to be the case? No, I don't know that to be the case. Let's see, we have a crossover here and a switching between crossover. Bad word to use. Switching between the transistors. And it sure looks like we have a bottom and a top. That suggests the transistors are good. Something about their operation is not so good. Some component adjacent to them, around them, Or is it just, yeah, no. I was gonna say, or do you just need a really strong AM station? No, a strong AM station's still gonna have that distortion in it. Assumably, that's what we're hearing, or that's what I've been hearing. That effect. The effect of that. So we know the signal is good here. Let's just go and repeat some of the stuff we did before. Oh, there's a flip. We'll go to the input to the output transistors. Input to the output transistors. Okay. What's all that about? And not saying too much because I would imagine that this should look like a nice sine wave here. I didn't really do a very good bias testing program here on this radio either. This is the other leg going to the other. It's exactly the same. It's exactly the same. Okay, what's on the input side here? So I'm going on the other side of the transformer now, the side that was fed by the transistor I just changed. There we are. Oh my gosh, look at that. That's the output of the transistor I just changed. Oh my gosh. Okay, input to that transistor is going to be on the base. Okay, just keep looking at the scope there. I'm going to try to touch the base here. If I can do it. Oh, why did it just get louder? If I touch the volume. Okay. There we go. That's the base. Oh, why there's nothing there? Let me try it again. Well, there's nothing there. There's nothing there. That's not right. Okay, so this is the output side of the transistor. You saw it there for a moment. And the other side. Why is there nothing on the base? Why is nothing appearing on the base? Can I say that again? Okay, I'll make my scope as sensitive as I can. Probes on ×1. Oh! Now that made it louder, but I don't know why. That made it louder. I clean it up. It's all fixed now. No, that's definitely not fixed. Back on the base. Oh, son of a gun. That's the base. Yeah. How can that be? How can that be? How can we hear this coming out of the speaker and see nothing on the base of the transistor that's driving it all? You can even see the look on my face, can't you? That's really quite the mystery to me how that could be. I'm going to stop for a little bit here, ponder this mystery of how did I get a reading of nothing on a base from a transistor that has a wild output. The mysteries compound.